Here's the final exam practice, and I'm going to do a review of the questions that come up for me while I do it. Since the questions are pooled, or some of them are pooled and some of them are not, you will likely see some questions that are the same as yours, but in other cases you'll just see those that are of the same objective type, but not the same question. Pulse rates of women are normally distributed with a mean of 77.5 beats per minute and a standard deviation of 11.6 beats per minute. Answer the following questions. What are the values of the mean and standard deviation after converting all pulse rates of women to z-scores using the z-score calculation that we actually obtained from Chapter 3 in its original form when they were sample with statistics, when it said x minus x bar over s. Okay, well, since what we are really getting at is what the standard normal distribution is made up of, we don't really have to do these calculations. In other words, if you're doing the z calculations, the z-scores, for what is already the mean, you should get a 0. And if you're doing the calculation for the standard deviation, you should get a 1. So this is kind of a concept question. You can run those calculations, but you would find that that would be the case. And actually, wait a minute, just a moment. You wouldn't be able to, well, yeah, you'd be able to run it. You'd be putting in 77.5 and minusing 77.5, and then you'd be dividing by 11.6. And then similarly, either way. So I guess you have to read between the lines. You have to understand what the question's asking. So 0 and 1. The original pulse rates are measured with units of beats per minute. What are the units corresponding to the z-scores? Well, they should be the exact same. So they should be beats per minute. Of course, I can't check the answer right now because this is in a review of a test format. So let's go on. Assume that adults have IQ scores that are normally distributed with a mean of 104 and a standard deviation of 15. Find the third quartile, denoted by Q sub 3, which would also be the 75th percentile, denoted by P sub 25, which is the IQ score separating the top 25% from the others. Right, so P sub 25 is the 75th percentile because it occurs 75% of the data the way through the data. All right, so how are we going to do this? We're going to need to calculate in reverse to find out what the x score is that corresponds to the z-score that cuts off 75% on the left and 25% on the right. But before we can do that, we're going to have to go find the 75% mark. There's another way we could do it if we wanted to use the negative z-score table. We could find the 25% mark, and then since the curve is symmetric for the normal distribution, remember this is the standard normal distribution, we could just make it positive. So since that's the first one I opened, I could come in here and I could say, okay, where is 25% under the curve? That would be 0.025, and I see 0.022, and then 0.025 is right here. What z-score does that correspond with? Well, I cite over to the left, it would be negative 1.9, and then the columns work like this. This is negative 1.9 exactly, so that's 0 right there. 90 hundredths. This is 91 hundredths, 92, 93, 94, 95, 96 hundredths. So it would be negative 1.96. Now again, that would be the one cutting off on the negative side, right? 25% under this, which would mean 75% was over here, but that's not what we're looking for when we're looking for Q3 or P75. So we would just make it positive 1.96, and that would be that cutoff value in terms of a z-score. Let me go ahead and go to the positive side, and we can just see the direct location of this. So we're going to look for, actually I can just scoot it up right here. We can look for 75%, which is the same thing as the third quartile. And I am looking, but I'm having a hard time seeing. Okay, so here is 74.54, which would turn out to be 75% rounded, and it's off by 5 thousandths essentially. This one is off by only under 2 thousandths, so that one would be closer. And this one is off by under 2 thousandths, but this one seems to be closer, so it looks like it would be 0.67. Now they should have matched up. So can you tell what I did wrong? Because if this is a cutoff point with 75% to the left, and that's how this works, it's area from the left. Remember that the normal distribution always is displayed in these charts as area from the left. Then this it should have gone to the same place. I'm sure that this is the closest one to 75% here. 0.67, 67 hundredths z-score. So then I must have made a mistake when I was looking at this. And let's see where my mistake may have been. I looked at negative 1.9. Okay, so you probably already have been able to figure out what I did. This is not 25%. This is 2.5%. If you move the decimal over 2, of course. So I should have been looking at this right here. And let's find out where that is. So that is negative 6.0, 1, 2, 3, 4, 5, 6, 7, negative 6.7. All right, now that I know that the cutoff score is 0.67 for the z-value, then I've got to reverse the calculation. In fact, what was that calculation? Well, it was demonstrated just in the previous question. That was the concept question right here. So I'm going to go ahead and grab that right there. And I'm going to work backward. I kind of like to remind you that during a test, sometimes you use the test to help answer your own questions, right? Little reminders here and there. So I know that this is 0.67, and for the distribution I'm dealing with, where I'm trying to find Q3, I have a mean of 104 and a standard deviation of 15. Oh, excuse me, by the way. This is the x value I don't know. A mean of 104 and the standard deviation of 15. All right, so just fill in what you have here, and then you use the algebra. Or if you just remember the reverse of all these steps in the first place, you should have multiplied by 15 to get rid of the 15 that it was being divided by over here, and then you should have added 104 to get rid of the 104 that was being subtracted there, and that would feed you right into the x value that we're looking for. Now, why aren't we settling with the fact that we found a cutoff score of 0.67? Well, it's because that's the cutoff score of 0.67 for the z value. But they're asking us in this question, well, it's implied in the question, that they want to know the actual IQ score. So which is the IQ score separating the 25% top and the bottom 75%? And that's why we have to go through the process of first finding the z-score that corresponds to that cutoff spot on the distribution, and then reversing the process to finding out which x value it is. Anyway, so what is the x value? All right, so we're going to take 104 and add 15 and multiply by 67. Now, if you type this into to a simple calculator, it would not follow the order of operations and you'd get the wrong answer. Mine's following the order of operations, so I've got 114.05. I'm sure it wants that many decimals. Oh, one decimal. 114.1 then. There it is. But if you were on a more basic calculator and you typed what I typed, I'll go back to it. 104 plus 15 times 67 hundredths you get 79.73. It's off. Well, that's because you as the user have to make sure you follow the order of operations, unless your calculator has the ability to follow and to use the order of operations. Speaking of calculators that have the ability to use the order of operations, and by the way, if you wanted to, you could have just used parentheses in your basic calculator. It would have forced that to happen even though you were typing it in from left to right, the way I had it written here. Okay, speaking of calculators that have the ability to use order of operations, several of you are using the TI-83 calculator. If you're using the TI-83 calculator, let me show you a very quick way to get our answer. Okay, I'm going to go back to the problem. Alright, so there is a function in your calculator already built to determine the corresponding z-score if you know the left area. If I can get the calculator turned on here. And you can use that to find the z-score. So I'm going to do so I'll do second vars, I believe is the one, which takes you to the distribution. There's a few more options if you're using the TI-84 versus the TI-83, and I'm using the 83, unless you actually installed the programs. But this option should be available to you in either case. It's inverse norm. It's going to request the left area under the normal distribution, standard normal distribution, and then it'll output what the z-score is that corresponds. But, and I'll demonstrate that, 0.7500, that would have 25% on the right and 75% right here on the left. So left area is what you need to put in, by the way. So it would get that 0.67 number that we were looking at on the table. This is a little bit more accurate, so you'll see that they've got 0.6744. Technically what it's doing is it's using the actual integration function, which is a calculus thing that we don't need since this is an algebra-based class. Okay, and then you can go through the process. But the process would be to take that answer you just got, to multiply the standard deviation, 15, and then to add, because we're undoing the whole z-score distribution, z-score calculation. So you'd add the mean, and so you get 114 and 1/10, and that's the same answer that we got, even when we had a rounding difference. But this tool has already been established to be able to go directly to the x values. So I'm going to go back to it. Again, second vars number 3. And I'll put in the left area that I want to have. And I don't need to put the 0, 0. I just put it because typically we use 4 decimal points for area scores to help us distinguish in our minds that in one case we're talking about an area score, and in another case we're talking about a z-score or an x value. So you don't have to put those. Then I would put what the mean is of this set that is non-standard, and what the standard deviation is of this set that is non-standard. So if you don't put it like I didn't up here, it will assume that it is a standard normal distribution, and we saw from question number 1 that means that the mean is 0 and the standard deviation is a 1. So it'll assume that, and it'll give you a calculation. So then obviously that must be the calculation that's actually on the z distribution. But if you put in the mean and the standard deviation here, it'll calculate directly to your x value, your non-standard score. So why do I show that? Because on the test you don't want to just know how to do something or what something's asking and how to answer it, but you want to know how to do it fast. So inverse norm, blah. And this question, which I spent minutes talking about, would have only taken seconds to answer. Incidentally, how would you know or remember that? Well, you've got a whole bunch of approved notes. Here's one set of them. This is the Appendix C from the Dropbox, and here's the normal distribution. This is the quick reference page. It tells you hit second vars, and to get a value, do inverse norm, left area, and then the mean of that distribution and the standard deviation of that distribution, and it'll give you the value. If you want the actual z-score, then leave those out, and it'll give you the z-score. There might be a purpose for you wanting that instead. Where else? There's also the graphing calculator review card. Just go all the way back up here. And I'm not going to go to the exact location here, but this would also have a place in more length to tell you how to do this. And where else? Let me get to the internet here. In the Tools for Success, there is the Graphing Calculator tutorial for statistics, and you could have found this under probability distributions. Normal, that's finding the area if you know the cutoff score, and then there's the normal distribution, finding the using inverse norm. There's actually a typo there, where you know the area but you want to find the cutoff value. And then it depends on if you want the actual cutoff value from the non-standard distribution or if you want the z-score. All right, now I'm getting a little lengthy with my answer here. I realize that it's not what you're going to want when you're reading this. So I'll go ahead and do one more question here, and then I'll start another set of videos so that way you can not watch this video if you don't really want to. Find the indicated IQ score. The graph to the right depicts IQ scores of adults, and those scores are normally distributed. How nice. With a mean of 100 and a standard deviation of 15. Okay, great. So we're looking at the z-score distribution, the normal distribution. And the indicator down here isn't a z, it's an x. And that's because it's not like this one that has a z, in the sense that this is the standard normal distribution, where mean is 0 and standard deviation is 1. This one, obviously the mean is 100 and standard deviation is 15. So could we do this really fast? Sure. Apologize. Okay, so we're going to have a 100 here for the expected mean, and a 15 there. And these are IQ scores. Our direct calculation is going to go like this. Second, vars, number 3. This is showing 90%. We put it in the decimal form, 0.9. And then we just tell ourselves that this is not a standard normal distribution. This is non-standard. So the mean, instead of being 0, is 100. Standard deviation, instead of being 1, is 15. I don't even have to close that parenthesis, in fact. Let's hit enter. 119.22. That would be this value right here. And they want it out to round to 1 decimal is needed. An IQ score of 119.2. Now it should make sense to you, because if you were thinking about the actual movement of standard deviations, your first movement of 1 standard deviation right here would be 115, right? And then your next movement of another standard deviation, so this is two standard deviations, would be 130. So it makes sense that this falls between those two numbers, 115, 130. And on the other hand, your movement of 1 standard deviation to the left would have been 85. Your movement of 1 standard deviation again, so 2 standard deviations, would have been, oh, what was that? Would have been 70. Let's stop saying maybe for the first thing, and then let's just answer questions. Let's go ahead and submit these 3 questions, see if we got them right. I know I didn't do all the questions, but whoop, what do we have here? Did I misread something? Oh no, I just got it wrong. I wasn't thinking. Yes, that's correct. Important correction. The z-scores are kind of like, like when you calculate a circumference and you're using pi, it doesn't matter. Pi is unitless, right? So like the z-scores here, they're unitless also, right? So I apologize. Right. If it wasn't unitless, it wouldn't provide us the ubiquity, and it wouldn't provide us the ability to use it all over the place like we do. So, good. All right, anyway, so let's move to the next set of questions, and I'll try to move through them a little bit quicker.